Hey guys, little video on vertical and horizontal asymptotes. So let me just show you what asymptotes look like here. I didn't plan to do this, it's going to mess up my screen a little bit. But let me show you what they look like. Asymptotes are areas on a graph that the graph will actually never touch. The function of the graph cannot have a value there. So that's going to get all messy here, but it'll be okay. So let me just show you some images of asymptotes. Right here, if you look at the bottom there, the red is the function. And it's got a vertical asymptote. You'll notice the graph will never touch where that vertical line is. And that vertical line is the asymptote. And it looks like it is there at x equals 3. So that graph will never touch x equals 3. And the denominator of that function, for example, might be x minus 3. Because at x minus 3, that function has, if that's in the denominator, that function will have a value of 0 in the denominator, which means it's undefined. So that graph cannot have a value at x equals 3, and it will just never, it will never touch across that line of x equals 3. You'll see that this graph also is a horizontal asymptote. So the graph will never cross that y equals line at y equals 1. And I'll show you what goes into finding the vertical and horizontal asymptotes for different graphs. And you can actually also have a diagonal asymptote, which the SAT and ACT barely ever ask about, but I'll give you just the bare basics you have to know so you can get these questions right. So we'll start out with the easier one, and it's the more commonly tested concept of vertical asymptotes. A vertical asymptote is all about where the denominator of the function would equal 0. Because whenever a function has a denominator of 0, it's just undefined. It cannot have a value there, and it will have a vertical asymptote there. So if we look at this function on this SAT math question number 36 here, in the denominator, they say for what value is the function undefined? It's any value that would make the denominator equal to 0. So all we would do is set that denominator equal to 0. And excuse my bad handwriting here. But that's it. And we would just solve that and figure out what x equals when it's 0. And I'm going to trust you know how to do that basic algebra, figuring out what x equals. So vertical asymptotes are just where the function's denominator equals 0. And in this other SAT question, we just set that denominator up equal to 0. And that one looks like you're going to get positive 5 and negative 2. And they say which of the following values of x would make this undefined. Positive 5 does not show up, but negative 2 does, so the answer would be B there. So that is vertical asymptotes. Pretty easy. And we can look at some ACT questions here. And you can see these are all the same exact principle. Where does the denominator equal 0? And on slightly harder questions, they might ask you about horizontal asymptotes. As just so you know that this is a supposedly harder ACT question. Number 59 out of 60. But if they're asking where that function is undefined, then that means they're asking about a vertical asymptote. And you would just try to figure out what value of x makes the denominator equal to 0. And you just end up solving for x. Whatever x is that makes the denominator equal to 0 is where the function is undefined. Therefore, it would have a vertical asymptote that the graph would never cross. Every once in a while, they might even question 60, of course, ask about a horizontal asymptote. And so for those of you who are going for 33, 34, 35, 36 on ACT math, you should know this. And I could see SAT math asking about a horizontal asymptote, although I haven't seen it before. But I think it's possible. So let me show you how to do horizontal asymptotes. It's actually nicely summarized in this YouTube video. And I'll get my face out of the way so you can see this pretty face of this young lady here. She explains it well, but actually it's all right there. So for horizontal asymptotes, what you do is check what is the biggest exponent in the numerator and the denominator. And I would copy this into your memorization list or your notes. Number one there, if the biggest degree of the numerator is smaller than the biggest degree of the denominator, you will have a horizontal asymptote at y equals 0. You just got to memorize this. If the biggest degree in each of them are equal to each other, you basically take the fraction created by the coefficients of just those terms that have the largest degree, and you'll see in her example here, number 2 there, it's x squared over 3x squared. The coefficients there are 1 and 3. It's 1/3. You will have a horizontal asymptote at y equals 1/3 in that particular equation or function that she gives you. And then in the third case, if the degree on top is bigger than the degree on bottom, you won't have a horizontal asymptote. I think you actually will have a slant asymptote, where the graph just never crosses at a certain slant. Let's say like y equals x, that line. I've only ever once seen slant asymptote mentioned or even vaguely referenced in a test. And I think it's this question 52. And if we look at question 52 right here, you can see in that graph, it's got a slant asymptote. It'll let me draw here. It'll let me draw? I'm surprised it's not letting me draw. Oh well. You can see, I'll do with my mouse here, there's sort of a slant asymptote right here. This function has a vertical asymptote going there, with an x-coordinate of 3, so h, j, and k are probably going to be the answer. And then the question asks, at what point do the asymptotes intersect? And you actually have a slant asymptote that's probably come through here. Not at 310, it's too low. Not at 331, that's too high. It's coming through right at like 316. And that's the only mention I've ever seen of a slant asymptote on one of these tests. So, vertical asymptote, easier, way more commonly tested. That is where the function has no value because the denominator equals 0 there, and therefore the function is undefined there. So you just want to find where does the denominator equal 0, and that's how you get vertical asymptotes. Horizontal asymptotes, you have to memorize this young lady's nice point here, and it's all about what's the degree of the numerator, the biggest degree in the numerator versus the biggest degree in the denominator. And you have 3 different things to memorize there, which is all laid out here in this image. So that's it.